Hello, let's review quadratic equations. Here what we have y equals x squared plus 16x plus 64, a quadratic equation. I simply set this equal to 0 to find my x-intercepts or roots or solutions, same names. That's simply where this particular graph, which we're going to talk about in a minute, crosses the x-axis. Here it doesn't cross, it just comes down, we'll touch it and go back up. Here we factored this. We got x plus 8, Solve, set both of these equal to 0. Your solution will be x equals negative 8. Here, notice it'll just come down, touch negative 8 for that x-intercept, go back up. This is a very rough sketch. 64 comes from this value here, which happens to be the y-intercept. The y-intercept is basically found by plugging a 0 in here, So now I have y equals 64. That's your value here. Here's a rough sketch. Just focus on the line. That's a parabola. Okay? Next, we have an inequality. Same concept. You simply graph the parabola first, which we've already done here. Then you have to determine by test points or just by remembering a little diagram that I'll talk about here in a minute. A little key on how to determine whether you graph shade up or down. The shading for this particular inequality represents all of the solutions for this particular inequality. Basically, if I did a test point, I chose the origin. Normally, that's the easiest point to choose if it's possible to choose it, unless it falls on the origin. Well, here I chose the origin. I plugged in 0 for y, 0 for x. 0 squared plus 16 times 0, that's 0. So now I have 0 is greater than or equal to 64. Is this true? Not in this plan. That 0 is not larger than 64. So here, for this particular point, this test point, this is false. Since this is false, I know that all of the ordered pairs above this line, and including this line, since it's greater than or equal to, will be the solution to this particular quadratic. And to test this, you could choose a point over here, plug it in to see that it's true, but you really don't need to do that. Okay, here's another example. Here we have a quadratic equation. We could graph this, but we're not. We simply want to look at this to determine what type of roots or solutions we have. And we're going to use what's called the discriminant. And with the discriminant, which is b squared minus 4ac, you substitute those values, your b, 5 squared, 4ac, into the discriminant. You simplify this or evaluate this, and you get a negative value. Well, your negative value will simply tell you that you have two imaginary roots. If this value would have been 0, it will tell you that you have one real solution. If this value would have been a positive number, it shows you that you have two positive solutions. Next, let's talk about what does imaginary solution really mean. It simply means, and it's kind of different, but the definition of imaginary simply means we've defined it to be imaginary because there's not a real solution, a real number solution. And what we have here is a graph on how to represent a imaginary number. Notice what we have. This represents kind of like your x-axis. That's your real number solution. This is your kind of like your y-axis, but it's your imaginary number solution. If I were to plot the point 3 plus 4i, you say the point, what are we talking about? Well, I can plot this, and I can even find the distance from 0 to that point. And the distance is called the absolute value of an imaginary number. So I'm going to go over 3 up 4. This is my point. If you visualize this is just 3 to the right, 4 up. Isn't that just a triangle? Well, if I wanted to find the absolute value of this particular function, all I do is just go use the Pythagorean Theorem. Well, here's the formula. It's going to be 3 squared plus 4 squared. You just take the square root of it. This one you probably recognize. You have a 3, 4 triangle. So it's a 3, 4, 5 triangle. This is 3 squared, which is 9, 4 squared, which is 16, square root of 25, which is 5. And this is your imaginary absolute value function.